Okay, cool. Basically, I'm just going to demo how to get from a CAD to a running CFD. So this is a CAD model coming out of Rhino. It has two parts. One is the hull part, one is the deck. And here is the Simerics UI. So Simerics is the all-in-one software, which means we do the pre-processing, do the model setup, run the simulation, and analyze the results all in one. So once we had the model ready, we can check what's the size and what's some features, especially for the CAD. It's an 8-meter long walking boat. And we're going to set up the mesh first. So it's very simple, basically, just just select something and it will make the mesh automatically. So for the marine template, so basically there's a bunch of options and we just need to select first like the hull type. Of course, this one is a planning because at the full speed, it will be at the full planning mode, but we can do that for the displacement, high speed and low speed displacement, as well as submerged body. We do the another type is resistant and powering. And the mesh size, for the demo purpose, I'm going to choose the cost, but I will show you how fast it goes if we pick other mesh later. And the deck into the deck category. We will define the sailing direction. So for this one, the forward will be -1, and up direction is a +z. And center of gravity is 500, and the point is roughly at here. So this will be our center of gravity. And the waterline position will be going through the center of gravity. So the relative to center of gravity will be 0. So by setting up all of those, that's all we need for the mesh, and we can start building the mesh. So less than 10 seconds, you have a mesh coming out. So you have the deck, you have the hull, you have the outside boundaries, and we set up everything. Not only the mesh, we also set up the physical module for you automatically. So we select all the necessary physics you need. And there's only two things before we can run the simulation. The first is that we need to provide displacement. And also we need to define how fast it goes. Say, let's put it 30 knots. And now we can save the simulation. And we can actually run the simulation from this point. So the simulation is up and running right now. And at the same time, we're able to do the post-processing. And just to show something, first is we can create the ISO surface, the free surface basically. And then we can plot the free surface elevation. As you see, while it's running, you can already see how the water clear out from the transom and how the bow wave starts here. And you are able to looking at some of the parameters here. For example, the resistance, you can review it while it's running. And as well as heave and pitch. Heave is going up and the pitch is going negative, which means it's bow up. And for this run, because we just running at a certain speed, so if we look at the forward velocity, we got a very quick acceleration. In 0.1 second, we reached our final speed and then let it run and settle down. We can look at the dynamic pressure on the hull. And for the post-processing purpose, we can also mirror it so that we get the full hull. So yeah, that's how quick and easy, like Rich mentioned, a couple mouse clicks, you're getting from a CAD model to a full run CFD. This one is currently running on the desktop.